Hello everyone, and in today's video I'll be covering combination and permutation for AMC math contest because you'll be seeing these questions a lot in all of the contests. And the list of topics that I'll be covering consist of combination with repetition, combination without repetition, permutation with repetition, and permutation without repetition. Okay, so what is combination first off? Combination is a method of selecting or distributing objects from a set into a subset. So for example, I have a red ball, um, a blue ball, and a green ball. And I want to select two balls out of these three. So how many ways do I have? How many ways can I do this? So first, since we have three balls, I can simply match up two of the balls. So, um, red and blue is one way, blue and green is another way, and red and green is another way of selecting two balls out of that set. So, I have three ways in total to select two balls out of these three. Okay, so what is combination without repetition? Combination without repetition is combination, but when you select or distribute objects, they cannot be selected or distributed repeatedly. So, for example, if you have three students and you want to pick two, how many ways can you pick? So, let's say I have three people here, and I want to select two out of these three students. So, how many ways can I do this? So first, we can identify whether this is a combination problem or not. So since the question states that you do not have to have an order to picking these students, we can identify that there is no order needed here, which makes it a combination problem. And the next step is to identify whether it there is no repetition or not. So we can identify this by looking at what needs to be selected. And since people cannot be repeated, we also know that these people cannot be selected repeatedly. So that is how we can identify whether this is a combination without repetition problem. Okay, so here are some more examples. So let there be a basket with five fruits in it, consisting of an apple, an orange, a banana, a cherry, and a strawberry. If you want to select three out of these five fruits in the basket, how many ways can you do this? So we can identify that this is combination because there is no order that there is no order needed, and we know that this is without repetition because there's only one of each fruit and you cannot repeat it. And another example is if a person goes on a 4-day trip and wants to bring four pairs of shoes and has eight different pairs, how many ways can they do this? So we can identify this as combination because there is no order explicitly stated in the question, and we can identify this as without repetition because they have eight different pairs of shoes, and those pairs of shoes cannot be duplicated. Okay, so what is combination with repetition? Combination with repetition is combination, but when you select or distribute objects, they can be selected or distributed repeatedly. So, for example, let's say you have like five ice cream flavors and you want to select three per one ice cream. How many ways can you do this? So, let's say I have five ice creams and I want to select three flavors for one ice cream. So how can we identify that this is a combination with repetition problem? First, we can identify that this is combination because in the question, it doesn't state that there needs to be an order between the flavors. And to identify if this is repetition, um, we I can have um, a chocolate flavor, a strawberry flavor, and a blueberry flavor, but I can also have 3 chocolate flavors. So we can just check if the objects in the questions that are to be selected can be repeated or not, which um, can help us confirm whether this is a combination with repetition question or not. These 2 factors help us determine that if this is a combination with repetition problem. First is the fact that there is no order needed, and the second one is that the factors can be selected repeatedly, which makes this a combination with repetition problem. Okay, so some more examples of combination with repetition problems are, let's say if you go to a bagel shop and you want to buy 4 bagels and there are 3 flavors to select from. How many different ways can you select your 4 bagels? So to identify whether this is combination, we know that this problem has no order needed. And to identify that this is repetition, since we have 3 flavors, so let's say they're I don't know, a chocolate bagel, a strawberry bagel, and a plain bagel. I can select like 2 chocolate bagels and a strawberry bagel and a plain bagel, which means that I can repeat the chocolate bagels, or I can just buy 4 chocolate bagels, which means that we can repeat the objects that can be selected. And for the second question, let's say a farm has cats, dogs, birds, and horses. And how many ways can you select 2 pets to take home? So if we have cats, dogs, horses, and birds, and you want to select 2 pets, you can select a cat and a dog, or you can select 2 dogs. And all of the animals are plural. It means that there are multiple, which means you can probably repeat them, which helps us identify that there is repetition and there is no order needed, which identifies this as a combination with repetition problem. Okay, so now that we're done combination, now we can move on to permutation. So what is permutation without repetition? Permutation without repetition is like combination, but when you select or distribute objects, they have to be in order and cannot be selected or distributed repeatedly. Okay, so for example, if you have 3 balls labeled red, green, and blue, how many ways can you arrange them in a row? So if I had a red ball and a green ball and a blue ball, how many ways can I arrange these 3? So we can identify that this is permutation because there is an order needed. Like I can make it green first and red in the middle and blue still in the back, or blue at the front, green in the middle, and red in the back. So according to this information, we can determine that this question requires order, and since the balls cannot be repeated, there is no repetition, which makes this a permutation without repetition problem. Okay, so now what is permutation with repetition? Permutation with repetition is permutation, but when you select or distribute objects, they have to be in order and can be selected or distributed repeatedly. Okay, so for example, using the numbers 1, 2, and 3, how many two-digit numbers can you make? So if you have the digits 1, 2, and 3, we can identify this as a permutation problem because um, if I take the numbers 1 and 2 and make 12 and 21, I can't just say that they're the same thing. So order matters. Except now we have to identify whether this is a repetition problem or not. So in the question, it does not say that the numbers can't be repeated, so I can also do 1, 1 to make 11, or 2, 2 to make 22. Which also means that the objects in this question can be repeated, which makes this a permutation with repetition problem. Okay, so now that we've covered the big picture of these topics, we can start moving on to the formulas. So let's start off with combination without repetition. The formula for this is n factorial over r factorial times n minus r factorial. In which where n is the number of objects and r is the number of objects being selected. And factorial means we multiply our chosen number by all the numbers listed in it, all the way down to 1. Okay, so now that we're done the formulas, we can start moving on to the questions. So we had an example from earlier that was, let there be a basket with 5 fruits in it, consisting of an apple, an orange, a banana, a cherry, and a strawberry. So if you want to select 3 out of these 5 fruits in the basket, how many ways can you do this? So first we can identify what n is, so what the number of total objects we have, which would be 5 because we have 5 fruits in the basket. And next we can identify what r is, which would be the number of selected objects, which would be 3 because the question says to select 3 out of 5 fruits. So taking this info, we can do 5 factorial over 3 factorial times 5 minus 3 factorial, which we can narrow down to 5 factorial over 3 factorial times 2 factorial, which gives us 10. Okay, so the next formula that we have coming up is combination with repetition. So the formula for this would be n plus r minus 1 factorial over r factorial times n minus 1, where n is the number of objects you have in total, and r is the number of objects you're selecting. Okay, so here we have an example for combination with repetition now that we're done the formula. So let's say you have an ice cream shop with 5 flavors, and for each ice cream you select 3. How many ways can you select 3 out of 5 flavors? So if we have 5 flavors, then n is 5, and if we have to select 3, r is 3. So we can do 5 plus 3 minus 1 factorial over 3 factorial times 5 minus 1 factorial, which then we can narrow down to 7 factorial over 3 factorial times 4 factorial, which gives us 35 possible combinations for this question. Okay, so now that we're done the combination formulas, we can move on to the permutation formulas. So permutation without repetition, the formula is n factorial over n minus r factorial, where n is the number of objects and r is the number of chosen objects. Next, we can move on to an example. So if you have 3 balls labeled red, green, and blue, how many ways can you arrange them in a row? So since we have 3 balls, n is 3, and since we're arranging 3, that means r is also 3, which means we can plug those into the formula and get 3 factorial over 3 minus 3 factorial, which gives us 6. Okay, so we can move on to permutation with repetition now. So the formula for this is just n to the power of r, where n is the number of objects and r is the number of chosen objects. Okay, so now that we're done reviewing the formula, we can move on to an example. So using the numbers 1, 2, and 3, how many 2-digit numbers can you make? So since we have 3 numbers, n is 3, and since we're making 2-digit numbers, r would be 2. So we can plug that in and get 3 to the power of 2, which gives us 9. Okay, so now we're going to move on to some math contest questions. So here we have a 2015 AMCA question. So, the Bluebird High School chess team consists of 2 boys and 3 girls. A photographer wants to take a picture of the team to appear in the local newspaper. She decides to have them sit in a row with a boy at each end and 3 girls in the middle. How many arrangements are possible? So, let's say we have 2 boys at the ends and 3 girls in the middle. So how many ways can we order this? So for step 1, let's first focus on the girls. So step 1. So since this is a permutation without repetition question, we can use the formula, and since there are 3 girls, we have n as 3, and since we're selecting from 3 or arranging from 3, r will also be 3. So we can plug these in the formula and get 3 factorial over 3 minus 3 factorial to get 6, which means there are 6 possible ways to order the girls in the middle. So now that we have the answer for the girls, we can move on to the boys. So for step 2, since we have 2 boys, n is 2, and since we're arranging 2, r is also 2. So this way, our formula would be 2 factorial over 2 minus 2 factorial, which is 2. So now that we have the answer for the boys, to add these up, it's going to be step 1 times step 2. So for step 3, it will be 2 times 6, which is 12. Okay, so before I explain permutation with repetition with types, I'm going to explain what grouping theorems are because it's an important piece of information to know before I explain. So let the number of different objects be n. Divide n into r groups, A1, A2 to AR, such that there are n1 objects in group A1, n2 objects in group A2, and all the way to n2 objects in group AR, where n1 plus n2 all the way to nr equals n. The number of ways to do so is n equals n factorial over n1 factorial, n2 factorial, all the way to nr factorial. So let's say I have 2 red balls and 3 purple balls. The group of red balls, we can group those into A1, and the purple balls we can group into A2. So that would make N5, N1, 2, and N2, 3. Okay, so now that we're done grouping theorems, we can move on to looking at permutation with repetition with types. So sometimes we are given a problem in which the identical items of type 1 are repeated p number of times, type 2 are repeated q number of times, type 3 are repeated r number of times, and so on. Okay, so now that we're done reviewing the formula, we can move on to an example. So for example, how many 8-digit numbers can be formed with the numbers 222, 333, and 44? So here n would be 8 because there are 8 elements in this set, and p would be 3 because there are 3 copies of 2 in the set, and q would be 3 because there are 3 copies of 3 in the set, and r would be 2 because there are 2 copies of 4 in the set. So in this example, the order of elements matter, and some digits are repeated. So we can substitute or plug in the values above in the formula below. So if we have p with the amount of repeated elements as 3, 3, and 2, and there are 8 elements in the set, we can substitute that as 8 factorial over 3 factorial times 3 factorial times 2 factorial, which gives us 40,320 over 72, which gives us 560. Okay, so before I present a way to solve complex problems, we first need to go over the fundamental counting principle. So when a task consists of k separate steps, if the first step can be done in n one ways, the second step can be done in n two ways, and so on through the kth step, which can be done in nk ways. Then the total number of possible results for completing this task is given by the product n equals n1 times n2 all the way to nk. Okay, so now that we're done covering the fundamental counting principle, we can move on to the strategy to break down complex questions. So sometimes permutation and combination questions can be pretty hard. So this is a way to break them down into simpler questions to make the process easier. So let's say you have your problem, and you can split the problem into cases. So you can break one down until case 1. And in case 1, you can break down part of the problem into steps and solve that particular part of the problem. So then you can do step 1 times as many steps as you have all the way to step n. And then you get the output for case 1. So now that you have case 1, let's say you need another case, so you can have a case 2. And then you can repeat the process in there and get the other output for case 2. And then you can just repeat this process all the way till case n. And then you can add all of these together to get the output or the sum of your problem. Okay, so now that we're done looking at the strategy, we can test it in an example. So for example, how many 2-digit positive integers have at least 1 5 as a digit? A 12, B 18, C 21, D 25, and E 35. So to use the strategy, we can first off start by splitting the question into cases. So for case 1, for step 1, when the ones place is 5, there's only one number 5, so that leaves only one choice. And for step 2, we can find the number of tens digits that can form 2 digits with number 5. And there are 9 ways. So when the ones placeholder is 5, there's 9 numbers that we can have. So for case 2, in this case, when there's a 5 in the tens placeholder as well, there's only one choice for the tens placeholder, which is 5. And for step 2, we can find that there are 10 numbers in the ones digit that can be combined with 5 at the tens digit. So that's 10 numbers. So, and the number 55 has both 5 in the ones and tens placeholders. So for the final step, we can add case 1 and case 2 together. So the total number of 2 digits that contain 5 are 10 plus 9 minus 1 equals 18. So the answer is B, 18. Okay, so here's a part A question from the 2015 AMC 8 to start us off. So the Bluebird High School chess team consists of 2 boys and 3 girls. A photographer wants to take a picture of the team to appear in the local newspaper. She decides to have them sit in a row with a boy at each end and 3 girls in the middle. How many such arrangements are possible? A, 2, B, 4, C, 5, D, 6, and E, 12. So this is a single case and only steps are required. So for step 1, we can find out how many ways there are to order the boys, which is 2 because there are only 2 boys. And for step 2, we can find out how many ways there are to arrange the girls, which is 3 factorial, which is 6. So then we can just multiply step 1 and step 2, which gives us 2 times 6, which is E12, together because we cannot separate them. So for step 1, we can arrange the 3 German books, 1 Spanish book, and the Arabic books together, which gives us 5 factorial. And then for step 2, we can arrange the 4 Spanish books within themselves, which would give us 4 factorial. And for step 3, we can do the same with the Arabic books, which would give us 2 factorial. So now we can multiply the steps together, which would give us 2 factorial times 4 factorial times 5 factorial, which gives us C, 5,760. Okay, here's our harder problem. So, an ATM password at Fred's Bank is composed of 4 digits from 0 to 9, with repeated digits allowable. If no password may begin with the sequence 911, then how many passwords are possible? A, 30, B, 7,290, C, 9,000, D, 9,990, and E, 9,999. So the solution for this is, in case 1, for this case, we will not consider that 911 is not allowed for the first 3 digits and calculate all possible combinations. So the formula for permutation with repetition is P N R, which equals N to the power of R. So N would be 10 in this case, and R would be 4. And then we can plug these in to give us
P 10 4, which equals 10 to the power of 4, which is 10,000. And for case 2, in this case, we'll consider that 911 is not allowed for the first 3 digits. So in this case, for the final digit, there are 10 numbers allowed. So we can add case 1 and case 2 together and get 1,000 minus 10 equals D, 9,990.